Recently, MoonBit introduced pattern guards. In pattern matching, you can add an if condition after a pattern. The corresponding branch will only execute when the condition is met. One application of this feature is simplifying expressions while performing pattern matching. In this basic simplification program, a pattern guard is used to check if A and B simplify to the same value. If they are equal, the subtraction expression follows a specific rule. Previously, this logic required an additional if statement inside the branch, adding extra indentation and redundancy. With pattern guards, the code is more concise and avoids repeating cases. Pattern guards can also be used with the as expression to introduce new bindings. In a JSON parsing function, if the input is an object containing a specific key, the pattern guard can extract and return the corresponding value. If the condition is not met, the match fails. This allows for structured deconstruction while keeping the code clean and efficient. The attribute syntax starts with a hash symbol, and everything following it on the same line is part of the attribute. It is similar to C++ directives, both in syntax and functionality. The first element after hash is an identifier, followed by a structured format resembling a subset of MoonBit syntax. Some existing directives, such as alert, deprecate, and coverage skip, have been migrated to this new attribute system. Additionally, an unused attribute check has been introduced, making these annotations more explicit compared to writing them as comments. When the deprecate attribute is uncommented, all references to simplify trigger a warning. The deprecation message, including parentheses, is optional. Similarly, coverage skip can be used to exclude specific code from coverage tests. The bytes type now supports initialization and assignment using string literals, which are stored as UTF-8 encoded bytes. Previously, string literals required a lowercase b prefix to be assigned to bytes. Now, a regular string literal on the right-hand side of an assignment can be used directly to initialize bytes. This conversion has zero runtime overhead, as the compiler directly transforms the string into a bytes constant during compilation. Escaping sequences are also supported, making initialization more convenient than before. Enums now support custom tag values, primarily for interfacing with native CFFI. So, these values like open flag here cannot yet be accessed directly or converted between integers and enums. This feature simplifies working with system APIs like open. Instead of writing a separate stub to map MoonBit flags to C integers, you can directly use constants defined in C, making FFI bindings more straightforward. Previously, const declarations only allowed literal values, such as const A equals to 1. Expressions like const A equals to 1 plus 2 were not permitted. Now, basic operations, including addition, subtraction, multiplication, and division, are supported, and constants can reference other constants in these expressions. We recently introduced a major breaking change to trait implementation. Previously, trait methods could be implicitly matched to top-level functions with the same name. For example, if a type T had a method named output, and a trait also had a method named output, the MoonBit compiler would assume that T implemented the trait. Now, we require explicit implementation declarations. You must use the impl syntax, such as impl show for T with output, to clearly specify that a type implements a given trait. This change ensures more predictable and maintainable behavior. We have also removed the ability to call methods using the T::F syntax directly. This behavior was previously deprecated with a warning. If you have been using the latest compiler and running format regularly, your code should have been automatically migrated. Otherwise, you may need to manually update your code to align with this breaking change. Previously, the native backend compiled everything into a single .c file, including various runtime utility functions required by MoonBit. Now, these utility functions have been separated into a standalone runtime.c file located in moon home lib